Hey there, good morning, geometry students. I hope that by now you've finished your test off and it was turned in yesterday and ready for a new chapter. Believe it or not, we are kind of approaching towards the end of the year, so that's kind of good. We've got some interesting topics coming up before we hit the end of the year. Hopefully we'll get a chance to be back face to face at some point before the end of the year, but if not, please just keep on. Start today's lesson, you're probably going to want to hit pause. And if you have a box somewhere, you're going to want to go grab a box and just have it in front of you. This would be something where we would have some objects in your hands, but the best I can do for today is to get it to be a little bit hands-on is for if you can go grab a box. It can be a box. It can be just any kind of a shipping box, just something that's a box. So if you just hit pause and go grab that, have it in your hands for today's lesson, that would be helpful. If not, follow along and you'll be fine. It just gives you one more level of a way to connect with this lesson if you can go and grab that. All right, so here we go. We're going to be talking about three-dimensional figures. So since we're going to be talking about three-dimensional figures, that's why I told you to go grab a box or something that you can hold in your hands. And that box that you have is formal name is a convex polyhedron. Okay, convex, you recognize that word from before, where basically what that means is that it doesn't have any dents in it. So it's not something that's in from outside, one that would be no dents in it. And a polyhedron is interesting, and that means that if you go around it, all of the faces or all of this three-dimensional shape are polygons. So we'll be looking at these a little bit more closely, but here are some examples of convex polyhedron. Okay, here's one. The sides of it are all triangles. Those are polygons. This one, we've got some triangles and a pentagon as a side. This one's like your box that we're going to be looking at. Your box may not be a perfect cube, but it might be stretched out, and that'll be fine. Here are some other convex polyhedron, no denting in. This one's kind of interesting. It's kind of like two pyramids jammed together, top and bottom. But you've got these different polyhedron, and all of the faces, in other words, the flat surfaces that go around the outside of them, would be polygons. Now that leads me to talk about a man named Leonard Euler. And Leonard Euler discovered a certain trait of these convex polyhedron. And he discovered this formula that compares the vertices, the number of vertices, the number of faces, and the number of edges. Now this is a pretty nice simple formula, and we're going to go over it and explain what it means, but I'd like to talk about Leonard Euler just for a couple minutes before we get going, because Leonard Euler is a pretty awesome individual, and please don't fast forward past this section. I'll include a bonus question on your test, maybe on your quiz also, about Leonard Euler, so you're going to want to listen and write some things down. Not all of them will be on slides, so you really do have to listen to this through. What makes Leonard Euler so awesome is that during the 1700s, you might be aware that, first of all, not educated and had the same access to education. And I would say that would be especially women were not really educated. The philosophy of the day was that women really belonged at home, weren't educated, and that there was no reason for them to learn to read or to write or to really learn anything. Leonard Euler, though, had a different opinion of that. He was a theologian. He was a very much belief in God out there. So what he did when he would go and he would talk mathematics and physics, he was a brilliant mathematician and physicist. You might read a lot of applications that he developed for algebra are still used today. He was really at the cutting edge of discovery at the time, and he was bringing mathematics and physics also very humble. When you dig into it and you look at who's responsible for an awful lot of the math you learn, you find out that Leonard Euler is the one who discovered an awful lot of it. However, he didn't brag about it very much. Now, the interesting thing is that I talked about the education. Leonard Euler really wanted education to be available to more than just the elite. He was willing to work and explain things to people, and even explain that to women. Um, King of Germany at the time was interested in having his daughter educated. And so what Leonard Euler began to do was write letters to this German princess. That would be a good thing to write down, not on a slide, but he wrote letters to a German princess, which you can still get a copy of today. The compiled letters that he wrote to her, educate her on subjects, physics, philosophy, mathematics, all the things that women were not traditionally educated in. And he would basically teach anyone he wanted to. I find that very interesting. Through wasn't able to face to face, and here I'm talking to you, not able to face to face, but able to talk to you and to educate you. In this case, through hearing, so through various other things, but this is what he did and what he was. Uh, One of the things he was famous for, the German prince, really, as I said, believed that education was important for everybody. He was, as I said, a Christian. He was fascinated by the design of the eye, and just as he began to study the various different aspects of math and science of the eye, he just marveled at it. This is just an impossible organ to have just come out of nowhere. And he proclaimed it as a wonderful gift from the Creator. If we're in class right now, I'd point at that picture in the back of the room that is of Leonard Euler. You've probably all seen it. He was actually blind in one eye through a whole series of things, and if you look up information on him, you would be able to find things about that. So if I were you and I was looking for bonus points, I would write down the idea that Leonard Euler did write letters to a German princess, and that is available if you search for it. You would be able to find some of his writings and the way that he explained, because it is public domain and you can get that for free online. So anyway, back to Euler. One of the things that he discovered is this nice, elegant, simple formula. V vertices, number of vertices, plus the number of faces equals the number of edges plus 2. And so when we look at this, if you just pick up your box for a minute, and I want you to understand what these different pieces and parts are. So if you pick up your box, so you've got it in your hand, what I'd like to do is I'd like to just count these vertices, the faces, and the edges. The vertices are those corners, so I want you to touch the corners of your box and count them. I'm counting 1, 2, 3, 4, 5, 6, 7, 8. Oops, I missed. But 8 vertices. All right, let's see if this will behave. 8 vertices. And then if I count the faces are the flat sides. So if I go through and I count the flat sides of this box, I've got 1, 2, 3, 4, and then the top of, and the bottom 5, 6. So I've got 6 faces. The faces are the flat sides. And then I want to go through and see if that equals the number of edges plus 2. So my edges are, let's see, I've got 1 edge, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 edges. I want to see if that 12 plus 2. So let's see, this is 14, this is 14. Yes, it does equal. They do equal each other. Now you can kind of see what the purpose of this would be if it's easy for you to count the corners and it's easy for you to count the faces, then you could calculate the number of edges. Or if it was easy for you to count the corners and it's easy for you to count the edges, then you can have that missing place, leave it as a variable, and count and find out how many faces that there would be. So you can do that with various different shapes. What I'm going to do is I want to take a look at another one. Let me see if it'll let me copy paste this whole thing so I don't lose it. Oh no, I didn't want to do that. Let's see here. Copy and paste. No, not doing that either. All right, well, try this. There we go. So I've got this I want to get rid of, and I want to apply this formula to one of the others and kind of show you what I mean about finding the missing pieces. So we're going to, yeah, I want to keep that. Let's get rid of this. Oh, let's keep this. Let's get rid of this. Let's take a nice big eraser. Get rid of all these things like here. There we go. Another one of these to the forefront. Okay, so this figure right here, okay, it's a triangle that's been, kind of a word for right now. We want to apply it and see if with it. So we've got our vertices. Let's count them. 1, 2, 3, 4 vertices. 4 vertices. The faces, 1 face on the front, then 1 back here, 2, 3, and 1 on the bottom. So that's 4. And that equals, we're given the number of vertices and the number of faces. You could calculate the edges pretty simply. So the number of edges would be 6. And 2, 3, 4, 5, 6 edges on that particular figure. So yes, it actually did work. So whatever you can count, you can use the formula in order to find the others. To verify formulas, you have to make sure that you are counting and just seeing that all of the math does work with that. So it's a pretty neat little formula. Let's look at another one. And here it comes back to that, but I'm going to bring the other one to the forefront. Getting rid of this nice big eraser. Boom, 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 boom. All right, here we go. I have this right here. This time I'm going to count. Vertices are pretty easy to count, so I like counting vertices. I'm going to do that. I've got 1, 2, 3, 4, 5, 6 vertices. Faces are kind of harder to count. I don't want to count faces, at least to the end. I want to use my formula. Let's count the edges. And sometimes you can actually feel and touch the edges. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means that if I do this little bit of math, I've got 6 plus f equals 12. And so that would mean that f would have to equal 6. So I'm expecting it's going to be 6 faces. To actually count that, you know, that there's 5 triangles going around the top and 1 bottom faces in that. So you can calculate a missing number. I want to do just 2 more so that you can get that. Now, the edge actually does go all the way from there to there. It's just for the counting purposes. I'm just making little pieces of it. Let's look at this one. This one's kind of smushed over, but it does count. It is a convex polyhedra. So let's go through and let's count. Like I say, vertices are kind of good and easy to count, so I'm going to go through and count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. And I'm going to, once again, I'm going to leave my faces for last, and let's count edges. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, plus 2. So 10 plus the number of faces equals 17. So the number of faces is going to have to equal 7. So we could check that out just to make sure. Let's think it through. There's 5 of these rectangles going around here. Top and bottom make 7. So we have Euler's formula once again working out. I would like you to go ahead and count your vertices, faces, and edges for this one. And you could pause it and go ahead and do that. And then I'm going to go ahead and do this. So, all right, your pause is over. So I have 1, 2, 3, 4, 5, 6 vertices plus number of faces equals 4, 1, 2, 3, 4 up here. 1, 2, 3, 4 down here makes 8, 9, 10, 11, 12. So 12 plus 2. So 6 plus f equals 14. So we're expecting there to be 8 faces. Okay, so 8 flat surfaces. There's 1, 2, 3, 4. You can see the 4 triangles up here and the 4 triangles down here. So once again, there are 8 faces. So hopefully that all made sense to you. You can find the missing pieces and you can go through and do a lot of good problems like that. I'll leave you to working on the assignment. I hope you found this lesson interesting, and I do miss you, and I'm praying for you, and have a good day today.